In this lesson, we'll talk about transformations. The idea is if you start with a function like f of x is equal to x squared, and you adjust it by maybe adding 3 or subtracting 2, how will that affect this graph? To figure this out, I'm going to choose a couple of points on this equation. So if I'm going to pick a few to work with, this is the point -2 comma 4. This is the point 0, 0. And then here is the point 2 comma 4. Where will these points go on the function g of x? Let's figure that out. So if I work with g of x is equal to x squared plus 3, and I want to see where this point goes on this function, I'm going to take -2, put it in place of x, and solve for the corresponding y value. So let's see, g of -2, that is -2 squared plus 3. All right, that is 4 plus 3, which is 7. So on the function g, at -2, we don't get 4. In fact, we get 7, so I'm going to plot that point here. Likewise, I'm going to check what happens for this point. I'm going to take the number 0, put it in place of x, and see what the y value is. So g of 0 is 0 squared plus 3, and that simplifies nicely to 3. So on this function, we don't get the point 0, 0, we get the point 0, 3, so it's here. And we'll look at one more point, that's this one here. All right, so g of 2 is 2 squared plus 3, and that is 4 plus 3, which is 7. So we get the point 2, 7 instead of the point 2, 4. I think I see what's happening. If I connect these points, we get a graph that looks like this. The difference between the function f and the function g is it looks like this one moved up a total of 3 places. And kind of looking back on it, that's really not a surprise. Here I have x squared plus 3. This 3 means add 3 to the y value, and this went up 3. So there's nothing special about the number 3. We could have picked 5 or 7, and the difference would be instead of going up 3, you would go up 5 or 7 places. Now, what about the graph of h of x is equal to x squared minus 2? If I were to guess, well, plus 3 went up 3 places. I'm thinking if we subtract 2, we'll go down 2. And to verify my guess, I'm just going to I'll choose this point here and see if it actually moves down 2 places. So what we'll do is use this point, which has an x value of 0. We'll plug it into this function and see what the new y value is. All right, so this is going to be h of 0, which is equal to 0 squared minus 2. 0 squared is 0, and 0 minus 2 is minus 2. In fact, the new y value is here at -2. We can check these remaining points, but the result of this minus 2 will subtract 2 from those y values. So we'll get this point here and this point here. If I were to sketch in the new graph, it's going to look like this. Again, not a perfect sketch, but you should have some idea of what this graph is doing. So this is what it means to be a transformation. We've moved the graph. And if I see a plus 3, we're changing the y value. It meant up 3. If I'm subtracting 2, we're changing the y value. We're going down 2 places. In example 2, we're going to start with a graph of f of x is equal to the absolute value of x. And the transformation we want to figure out is g of x is equal to the absolute value of x minus 4. How is this different than this? Well, for starters, I see this minus 4 here. And last time we saw, okay, that meant go down 4 places. But that doesn't happen this time. This is very different. This minus 4 is directly next to the x. In fact, it's inside the function. This means we're changing the x values and not the y values. So just to make a note of that, this is going to change the x values. So instead of an up or a down, this graph is going to go either right or left, and we have to decide which way it goes. One thing I'd like to add here is anytime that you change an x value, it's going to have the opposite effect of what you expect. So let's make a note here that will have the opposite effect. So it's tempting to think that, okay, this graph is going to move 4 places left because subtracting goes this way. But actually, this graph is going to go right 4 places. And the question is, well, why does that happen? So with the function g of x is equal to the absolute value of x minus 4, the way it's written here, let's focus on the point 0, 0 on the original graph. So here's 0, 0. The reason you get 0, 0 is because if you put 0 into the absolute value function, it's the absolute value of 0, which is 0. Okay, over here on the function g, what number do you put in place of x so you get the absolute value of 0? Like, what if you want to have a 0 in here? The number that you have to put in place of x is 4. So that means g of 4 is the absolute value of 4 minus 4. G of 4 is the absolute value of 0, which is equal to 0. That means when x is equal to 4, you get a y value of 0 back, which is right here. So this point, it was at 0, 0, but it went over to positive 4, so we got 0 back for the y value. This is very strange. It's not what you would expect to have happen. But the thing to remember is if you're changing an x, you should expect the opposite effect on your equation. So not only does this point go 4 places to the right, every point on this graph is going to go 4 places to the right. So we just need a couple others to work with. I think maybe I'll take this point and move it 4 places to the right. So it goes over 1, 2, 3, 4. We get this spot here. And then this point goes 4 places to the right, so 1, 2, 3, 4, and we get this point here. And the entire graph moves in this direction, and so this is the equation. This is the graph of g of x is equal to the absolute value of x minus 4. So the thing to point out is a number inside the function, it changes the x values. If that happens, it's going to have the opposite effect of what you would expect. So not left 4, but right 4. And if you can remember that, you can then move the points where they need to go. Let's combine the ideas of examples 1 and 2 here in example 3. So I have a graph of the absolute value of x, and let's first sketch a graph of g of x, which is the absolute value of x minus 3 plus 4. What does this thing look like? Now, if you look at the differences between this and this, I see a minus 3 and a plus 4, so there's definitely 2 things that are different. This minus 3 is affecting the x values because it's inside the function, and the fact that it's minus 3 and that it's changing the x's is going to have the opposite effect of what you would expect. So it doesn't go left 3, in fact, it goes right 3. The second thing that this graph will do is now add 4. Now this is changing the y values because it's outside of the function. A plus 4 is going to move the graph up 4 places. If you want to graph this thing from the original equation, we can take every point and put it through these 2 steps. So I think maybe the simplest one to start with would be, well, what about this point here at 0, 0? Where does it go? Well, it goes right 3, and it goes up 4. 1, 2, 3, 4. This is the new location of that point, 3, 4. Now maybe we should get a few more points just so we have an accurate picture. Maybe I'll choose this point here. Again, it's going right 3 and then up 4. So this is the new location of that point, 0, 7. So I have these 2 points. Maybe I'll choose this one right here. Where does this point go? It goes right 3, and it goes up 4, so this is the new location of that point. I think I have enough to see what this new function looks like. Looks like this. So the entire graph moved right 3 and then up 4. Well, what about the function h of x, which is the absolute value of x plus 2, then minus 2? Again, there are two differences. The order in which they happen is you work with inside a function or parentheses first, and then you would subtract. So the first change is coming from this plus 2. That's changing the x's because it's inside the function, and the opposite effect would be that it goes left 2. This minus 2 is changing the y values because it's outside the function, and if you're subtracting, you're going to go down 2 places. So, I think I'll use these same 3 points. I'll put them through these 2 steps to see where this new function is. Let's start with this one. First it goes left 2, and then it goes down 2. So negative 5, 1 is the new location of that point. Here, this goes left 2 and down 2, so negative 2, 2 is the new location of that point. And the last one is this one. It goes left 2 and down 2, so it's actually right here. We're going to have a little bit of overlap. This is something that can certainly happen. If you sketch in the entire graph, here is h of x. One last thing to point out is that I used 3 points in determining where these new functions were located. You can use as many points as you'd like. Like 1 might be enough. If you know where this spot is, it's very easy to sketch the entire graph and around it. But that is everything for this example. In the previous examples, we were adding or subtracting. And here, I'd like to take a look at what happens if you multiply by like 0.5 or maybe a negative number like negative 2. How is that going to affect this graph? And here we'll use f of x is equal to x squared. This 0.5 and this negative 2 are affecting the y values because they're outside of the x squared function. So I know this is changing the y's, and that means it'll have the effect that you would expect on the graph. So I think what I'll do is I'll choose a couple of points. I'll choose, let's say, maybe negative 2, 4, 0, 0, and 2, 4. I think those are 3 good points to work with. So negative 2, 4, 0, 0, and 2, 4. What happens to these points on the function g of x, which was 0.5 times x squared? I'm going to start with this one here. I'll take negative 2, put it in place of x, and see what happens. So g of negative 2 is, it's 0.5 times negative 2 squared. G of negative 2 is, okay, so it's 0.5 times 4. And, well, that's really half of 4, and half of 4 is 2. So this point was at 4, and now it's down at 2. So it looks like it just, moved down 2 places. Maybe the same thing will happen to this point. Maybe it will go down 2 places. So let's just, carefully check this. So to check the point 0, 0, I'll put 0 into the new function g. That's 0.5 times 0 squared. Let's see, 0 squared is 0, and 0 times 0.5 is 0. So actually, this point did not move. It stays right where it is. So when you're multiplying, it's not a shift. It's not an equal movement down. In fact, what we're doing is taking half of every single y value. The y value here was 4, and half of it is 2. The y value here is 0, and half of 0 is 0. Using this as a model, the y value here is 4, and half of 4 should give me 2. If I draw the graph that goes between these new points, I get something that looks like this. So this is not a shift. This is often referred to as a shrink. Points that are at 0 stay at 0, and everything else is shrinking, in this case, down towards the x-axis. And it kind of makes sense. This equation to me says, take half of every single y value. And this is the net result of that equation. Well, what about h of x? What happens here? One thing to think about is, okay, well, this time I've multiplying by 2 instead of multiplying by half. I'm thinking we're going to double the y values. So it's not going to shrink, but maybe it'll stretch. But we also have this negative, so that will have an effect as well. Let's take this point here, negative 2, 4, and let's see where it goes. So I'll take negative 2 and put it in place of x into this new function. So it's negative 2 times negative 2 squared. So that's negative 2 times 4, and negative 2 times 4 is negative 8. So this y value here on the original function was 4. It definitely doubled to give us 8, but that negative actually reflected it over the x-axis down to negative 8. So the new location of this point is at 2, negative 8, which is right here. So this is actually like two things happening. First, it doubled to give us 8, but then it reflected over the x-axis. So this is acting as a mirror. The point 0, 0, if we use this logic, actually stays right where it is. The y value here is 0, and if you multiply that by negative 2 times 0 is still 0. The point that's located here, okay, this y value is 4. If you first double it, it goes up to 8, and if you multiply it by negative 1, it goes down to negative 8. So the new graph looks like this. So two things happened in this new function. There was a stretch, but also a reflection. If you see negative numbers, you're going to reflect over an axis. And if you're multiplying to a y value, it'll either shrink it, because we're taking half of it, or it will double it, and we're stretching it. Okay, in our last example, example 5, we're going to work with f of x is equal to the square root of x. So maybe just to label a couple of points on here, you get the point 0, 0. And if you put 4 into the square root function, you get 2 back. Those would be two good points to work with, 0, 0, and also 4, 2. What does the new graph, g of x is equal to the square root of 0.5x, look like? What is this new function? Well, one thing to point out is this 0.5, it's now right next to the x. It is inside the function. So we are changing x values. So this is going to change the x's, the x values. So I'm expecting an opposite effect. You would think it would take half of the x's, but the opposite effect would be to double it. This 0.5 here turns out that it doubles the x values. So to think about what this new function will look like, you can look at the x value of this point, which is 0, and if you double 0, it actually stays right where it is, at 0. Now this point has an x value of 4, and if you double 4, that gives you 8. The new function looks like the square root function, but it goes through these points, and so you get something that looks like this. So that's the function g of x. We're doubling the x's. Now, why does that happen? Like, why do you double instead of take half of the x values? So here's why. This is the point 4, 2 on the original function. The reason it is because if you put 4 in place of x, you are taking the square root of 4, and that gives you 2. So right, you get the point 4, 2. However, if you look at the function g of x is equal to the square root of 0.5x, if you want the thing under the square root to equal 4, if you want this whole thing to be 4, the number that you have to put in place of the x, it's not 4, it's not 2. In fact, it's 8. You have to put an 8 here because half of 8 gives you 4 back. So just to write that out, you have to put 8 into this function so that when you multiply everything under the square root, it gives you the square root of 4, which we know is 2. Changing the x's is strange. You have to kind of like think backwards. You have to think about a number that'll work nicely within the function. But that is it for this example.